Hello, you're welcome to New Focused Approach to Mathematics Basic 8. This is the revised edition, and in this lesson, we are looking at expressing integers in standard forms, or we call it scientific notation. So, what is standard form? What is scientific notation? It is the way of writing a very large number or very small number in a simple way. If you are doing experiments with science, or you are doing calculations and you are doing measurement and you are measuring a very large object, okay, and the value is very huge, you can't be writing that huge number in your calculations. For example, instead of writing 48 million and that you are using it in your calculation, it will be very simple if you write 4.8 times 10 to the power 7. I'll show you how it happened very soon. Or instead of writing 0.00000056, that is quite big, okay, in writing, or quite small number, which we can say is approximately 0, but we need it because of calculation sake. We can simply write 5.6 times 10 to the power negative 9. We'll come back to know how to write this to that, okay. So when we talk of scientific notation, that is all we are trying to say. Or writing huge number in smaller form, or in the simplest form, or small number in the simplest form. Now let's look at how to identify standard form, or how to identify scientific notation. We are going to come up with some few rules. The first rule is that the first number should be non-zero number. Anytime you want to write a number in a scientific notation form or standard form, the first number should be non-zero number. That means your first number here shouldn't be 0 point something. No, it must always be a number. It must always be a number. So you can't write maybe 0.4 times 10 to the power something. I mean, it's not that. The first number here must always be a non-zero number. That is number one. Number two, any number between 0 and 1, the exponent on the 10 should be negative. That means if the number is small, less than 1, okay, very small number less than 1, or between 0 and 1, like 0.003, like 0.972, all those numbers, when you put them in the standard form, you must always have negative as your exponent. Example can be this. If I have this number, I can write it like this. And because this number lies between 0 and 1, the exponent here is negative 9. And very soon I'll teach you how to write it, okay? Or I can even start from here by saying that to write this one in the standard form, okay, you just move the decimal point backwards 1, 2, 3, 4, 5, 6, 7, 8, 9. It must always be in between the first two non-zero or first two significant numbers, and so that 9 will give you times 10 to the power negative 9, right? Then the third rule says that any number greater than 1, okay, the exponent on the 10 must always be positive. For example, if I want to write 48 million, I will just start from there. You see, any whole number has a decimal point at the last end here. For example, if I write 72, it's the same as we saying 72.0. I mean, it's the same thing. If I write 132, the same as saying 132.0. It doesn't change anything. It's the same thing. So the decimal point is this. So I'll move it backwards 1, 2, 3, 4, 5, 6, 7 to the first two significant, in between the first two significant numbers, will give me 4.8 times 10 raised to the power positive 7, because the number here is bigger than 1, right? So let's take an example like this. The distance from the earth to the nearest star is approximately, how will I call this one? Wow, big. Okay, let's see. So 1, 2, 3. So this is million, this is billion, so this is trillion. So 25 trillion. Okay, so 25 trillion, right? 25 trillion, because there's no number here to mention again. So 25 trillion miles. And I want to express this in a scientific notation form. So what we do is that, and it's a whole number. So we start from the decimal point here and move backwards 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 2.5 times 10 to the power 13. So that is how we write this huge number. Can be written in a very simplest form, that is 2.5 times 10 to the power 13. Okay, let's say the last example. Atomic mass of a certain element is 0.000000000000000000052 kilograms. That's amazing. Very, very small number. Okay, and we want to express this number in the scientific notation form. Okay, so we go from here. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we get 5 points. So always put it in between the first two significant numbers. So it will be 2 times 10 to the power negative 20, because it's a very small number. And when we move from left to right, it's always negative. When we move from right to left, it's always positive. I'm sure this has really helped you to know how to write numbers in scientific notation form or standard form. Thanks so much for watching.